These men are building the longest bridge of its type ever attempted in North America, but they're doing it in the worst possible place. In Charleston, South Carolina, where hurricanes, earthquakes, and the world's biggest container ships pose a deadly triple threat to the bridge and to the workmen building it. If they succeed, Charleston will manage to remain one of the nation's most vital ports.
I plan for this bridge to last forever.
But if they fail, this flower of the South may fade into history once and for all. "6:30 a.m. in Charleston, South Carolina. A steamy Monday in June. Near the mouth of the Cooper River, a crew boat eases from its dock and heads out into Charleston Harbor.
Morning.
On board, 20 bridge builders, headed to work on the construction site of the new Ravenel Bridge, a long overdue replacement for a pair of decrepit steel spans. Cable stay structures are the hottest thing in modern bridge construction, and engineers around the world are trying to outdo each other with even more daring designs. On a cable stay bridge, the deck hangs from steel tethers anchored high up on the main towers. They're known for their sleek lines and simple beauty, but they're notoriously tough to build. The longer the span, the longer the cables, and the bigger the challenge to builders. When completed, the Ravenel Bridge will be the longest cable stay bridge in the U.S. Since 2002, this crew has erected 2 550-foot concrete towers, built 2 interchanges, and nearly completed both elevated approaches. Now, they're hanging the bridge's 64 road deck sections. Thousands of tons of steel and concrete dangling 200 feet over the Cooper River. To stay on schedule, these guys need to assemble a new deck section every 5 days. That means hanging girders and floor beams, picking and placing concrete slabs, pouring connective concrete, and stringing and tensioning cables. And while this boatload of guys does what it needs to do here on the West Tower, another bunch of guys is doing the same work over there on the East Tower. The objective? To meet in the middle and call it a bridge. For most of these men, this is the biggest job they'll ever take on. It's also the most hazardous. These workers spend 12 hours or more per day stranded on this narrow island in the sky. They depend on each other for their lives, now more than ever. Just a few weeks before, a steel worker plunged to his death after failing to attach his safety harness. So these days, Superintendent Everett Gibbs drills into the heads of his men the danger lurking everywhere.
Today, we're going to hit a couple quick topics on our basic safety rules that we seem to be having a problem with. The first is safety glasses. You lose an eye. When you lose it, you lose it. Everybody on the same page?
Since the fatality, failure to tie off carries serious consequences.
If you are not tied off, you are fired. Period. Period. You have kids, wives. Don't let this be your last job.
How's that for motivational speaking? Day 1. The crew is getting ready to hang another segment. 50 feet of brand new real estate.
Now's when we get creative, because we're going to run into this every time from here out.
They've done it several times already, but they've never had to do it under so much pressure. The first deck sections were part of a learning process and took weeks to complete. But those days are over.
Let's go! Come on! Come on!
They have 44 segments to go, and now they've got to shift into high gear. Because Charleston sits smack in the middle of Hurricane Alley, and the crew finds themselves smack in the middle of hurricane season. Most everyone on this job site remembers the destruction Hurricane Hugo brought to Charleston back in 1989. 10 years later, it was Floyd that did the drubbing. And now, just as deck construction is underway, forecasters say the East Coast is overdue for a major hurricane. To bridge workers like Dave Vanna, every foot of deck they hang and every day that passes without a storm feels less like luck and more like the run-up to a terrible reckoning.
If you look over at that tower, look over that way, before these are connected, there's this big massive roadway just hanging there in the air. Until we're connected and everything's locked together on the shores, it's a very big, vulnerable piece of weight sticking up there.
And it's getting bigger by the day. Now, as the next construction cycle gets underway, the men are taking care of some unfinished business. A concrete pour has been scheduled to put the finishing touches on the road segment they completed the week before.
Incoming! All right, let's see some action here. This weighs 17,000 pounds.
The name of the game? Get 85 tons of concrete into the gap between the deck panels.
That's a Georgia buggy, they call it. Why? I'm not sure. I'm from Maine, and that's Georgia's down south. You're gonna have to ask one of these southern birds that.
They've got to get the mud in the hole, as the guys say.
It's a touchy mix. You
You've got 3 hours supposedly from the time it's dispatched to the time it's delivered. It means it's got to leave the plant, go to the dock, offload it on the barge to here to us.
And it's got to settle to the bottom, which takes a lot of coaxing.
Well, that concrete's still good. You get it in there and get the vibrator to put it in, and if it'll level out, it's all right.
The vibrator makes sure the mud settles, until finally they can flatten it out, smooth as a baby's butt. Once upon a time, these antique spans were sufficient to carry Charleston's 65,000 cars each day, but not anymore.
We knew that the old bridges had to be replaced because they were getting very, very old. Structurally, the old bridges were a 4 out of a possible 100.
Simply put, the old bridges are accidents waiting to happen. Not only that, but today's biggest container ships simply can't fit beneath them. Chris Thornton has been piloting ships like this under the old bridges for 15 years. At low tide, these babies just barely squeak by.
The bridge when I first started wasn't an issue, but now it seems to me that every ship has an issue with it. We have to monitor the current and the stage of the tide to get under the bridge.
If Charleston can't accommodate bigger ships, it could become a second-rate port. But squeezing the $600 million for a new bridge out of state and federal coffers would take a special kind of person. Someone with vision and, more importantly, clout. It took State Senator Arthur Ravenel, a man with a lifetime of political favors just waiting to be cashed in.
You go to people and you ask them for big bucks, they're a little bit reluctant to open their wallets. But everybody came around, and the bridge is being built.
The state decided to name the bridge after him, while he's still around to enjoy the honor. Today's work on last week's deck section isn't done until the quality control or QC guys say it is. James, Dave, and Mickey are the first line of defense in making sure the bridge will last its promised 100 years or even longer.
10-4, me and Todd are on the west right now.
The existing bridges aren't anywhere near that old, but both are already obsolete. If this bridge is going to last forever, there can be no shortcuts.
We got painters coming here around August, September, I believe, and it's got to be clean. You have to have a clean surface for the paint to stick to.
They're snooping around under the deck, and they found a problem.
Anywhere there is drippage of concrete under here, we can't have it.
Concrete has been seeping through the cracks, and now it's starting to harden.
This might be the worst. Mickey and I took a look underneath segment 205 after they poured that infill pour, and there are several areas where they had leakage. It's just a problem of access down there right now. There isn't a good place to tie off and get workers down there. As the concrete pour is going on, to get the concrete off when it's still wet, which would be the easy thing to do, of course.
Pressure washing.
Right. But access right now is a problem, so...
Right. Well, they're going to have to make access to get it done.
Yeah.
That's just all it is to it. So if we get that done, and from here on out, if they pressure wash right when it's poured or within 6 to 8 hours after it's poured, it can be removed.
But if they chip it off, it could affect the paint, it could affect the girder, you know, and so on.
I'm going to bring this back to the office,
Okay.
discuss it with Marvin, and then see how he wants to handle it. I know there's priorities, but this is a priority also.
Nice catch, guys. They've got the safety of the longest bridge of its type in the Americas riding on their shoulders. With pressure like that, they need to kick it out now and then.
Working with the guys on the job site, making sure everything is done per spec. It's a double check, triple check system, and we have people that check us, and that's what quality is. We're not looking at something very small. This is a very large endeavor, and you have a lot of people's crossing it, so we have to make sure it's safe. This is therapy. I mean, it really is.
Day 2. The crew has burned an entire day of a 5-day schedule finishing last week's deck section. To meet their deadline now, they'll have to do in 4 days what is usually a stretch to get done in 5. They're ready to attack the steel for this week's deck section. Massive floor beams that are just arriving by truck. About a mile upriver at a former Navy yard, now a staging area. Each of these floor beams is 126 feet long and weighs 25 tons. It'll take 2 precisely coordinated cranes to get each one of these puppies onto the waiting barge. Each truck deftly positions its load, and then the ballet begins. A dance between man, machine, and monster chunks of steel. It takes half a day to get all 300 tons loaded up. Now all they need is a tug to get them down the river to a crew of anxious and bored ironworkers. They wait and wait and wait a little more. But by the time the steel arrives at the bridge, it's already nearly 8 p.m. The question is, should they call it a day or press ahead? Their schedule is slipping, and the bridge needs this iron. Good thing these iron workers are a special breed. This is not a crew that puts off till tomorrow what they can get done now by working all night long.
Cabling on up.
There's nothing newfangled or high-tech about their job.
Give me a little bit of left-hand swing.
Just 10 men, a crane, and a radio.
Boom down. Maybe a little bit of cable up.
To get a couple of 40-ton pieces of steel to fit like a glove.
Hold that. Bring it right.
Once the girders are in place, workers slam steel pins through bolt holes. Only then do they get the pleasure of cranking home all 494 bolts. Every bolt and nut that goes into the bridge is hand-picked and matched by type, size, and load-bearing capability. And Lance here is the brains behind all the bridge's nuts.
In the main span of the bridge, there are 172,000 bolts. 61.2 tons of nothing but nuts, bolts, and washers.
How many of those things you put together in a day?
If I'm going to be on television, 1,200. If you or my boss is not here, 800.
You getting carpal tunnel syndrome?
You using those fancy words, you got one for bored?
How do you cope with the boredom?
I'm not really here. Just last week I was deep sea fishing and Paris Hilton was the first mate on the boat.
Good one, Lance. Does it matter how the nuts go on?
Yeah, nut goes on the threaded end. Washer goes between the nut and the head.
You feel a little neglected out here?
Sure, I'm not very sociable. In fact, talking to you is about the most mouth running I've done in a long time, and I'm getting kind of tired of that.
Day 3. Daylight reveals that the night shift pulled it off. The steel is up and ready to receive the panels. Thanks to the iron workers' determination, the crew seems to have reclaimed a good chunk of their schedule. But there's still one more job to do before they can lay the concrete deck panels. The cables need to be strung and tensioned. And it can't get done until this guy, Bridge Inspector Russ Touchberry, is there to oversee it. Russ is one of the lucky guys charged with making sure mess-ups don't get overlooked. And if there's one bridge element everyone wants to be sure is perfect, it's the cables.
A lot of people actually wonder if the cables are simply there for looks. No, that's definitely not the case.
The cables hold up the road deck, period. And they're a lot more complicated than they look. To string the cable, a crane attaches the long white tube that gives the cable the appearance of being a single strand. But it's just a protective sheathing through which the actual cable strands are fed. Up to 100 plastic-wrapped strands can be in one white tube. And each strand consists of 7 individual wires sealed with a coating of wax. When it's finished, the bridge will have more than 5,000 miles of individual wires in its 128 cables. End to end, that much wire would reach to the West Coast and back. The strands are pulled up through the sheathing 2 at a time using a motorized shuttle. Russ's job is to make sure they end up where they belong, problem-free.
If we have a case where there's actual strand exposed, then that needs to be fixed by that repair procedure. So that's what we're looking for.
Once strands are inspected, they have to be tightened 200 feet up inside the towers. Luckily, there's an elevator and Dave Vanna to operate it.
What happened? Well, we're in the middle of a small minor crisis here. Yeah, the power, it shut off on itself. I'm coasting down on the brakes, Brian. Yeah, as we're going to the top, as you know, we're holding the camera. Our umbilical cord that runs this elevator up actually got snagged down below on something, tangled up, and it actually pulled out of the power supply. So right now we're in the emergency elevator mode. The only problem right now is our cables are going to be stopped for a day while we fix this problem.
It's not only Dave's problem. There's a guy up here working on the cables. If he doesn't catch a ride down right now, he'll be stuck for the duration.
Get your harness on, please. Dig deep, a long way down, and I don't want to have to fire. Right now we've got about approximately 200 feet to go before we can get off, and we're working on fixing it. That smell is the actual brakes. That's the brake pad, and you can smell them getting warm, so.
But then when they overheat, we get a quick ride at the bottom.
Yeah, if that's true. Hold up. The elevator is out of service.
Turns out that the power cable got snagged and it snapped.
Tell him to bring the electrician back up. Chubby's got to get the elevator fixed. What's going on, Louis? Yes, I tore the elevator up. Even I make mistakes.
Cable tensioning will just have to wait while Dave decides how much to charge the Discovery Channel for busting his elevator.
But having the TV camera guy in there with me coasting down, I guess they want to show. They're going to get a show, I guess, of what we have to go through.
Hopefully, they won't suffer anything worse than a broken elevator. But in Charleston, anything is possible. What most people don't know is that the city sits directly on top of the most seismically active fault line in the eastern U.S. The last major quake, measuring 7.0 on the Richter scale, devastated downtown Charleston and killed 60 people. That was in 1885. Today, seismologists predict that another killer quake will almost certainly rock the bridge sometime in the coming century. Bridge designers say, bring it on. They've engineered this baby not only to withstand the next big one, but to last 100 years, at least. They began by making the towers rock solid. Because of the tremendous load the bridge would bear during an earthquake, the footings had to be deep, real deep. For each tower, 11 steel cylinders, each 10 feet in diameter, were sunk nearly 100 feet into the dense clay at the bottom of the river. The shafts were dug even deeper, to a depth of 230 feet. With mammoth rebar cages inside the steel casings, encased in nearly 1,500 tons of concrete. The result? Footing strong enough to support the towers in a major earthquake, but not strong enough to withstand a direct hit from a container ship. That's no Chicken Little scenario. It's happened before. In 1946, a runaway ship took out a main span, spilling a family of 4 in their car into the Cooper River. In the last 25 years, ships have twice run aground to avoid colliding with the bridge. So this time, designers decided to do something about it. They surrounded the towers with protective rock islands crafted from 17 shiploads of Canadian granite. 700,000 tons of the stuff. Enough rock to create 5 acres of stone on the riverbed and an acre at the surface.
It's hard to appreciate the rock islands because you really don't see them. All you see is just the top. It's almost like the island of Hawaii. You just see the tops of the old volcanoes.
With a base 5 times larger than the top, the islands slope up from the bottom of the harbor to stand as impenetrable shields between a runaway ship and the bridge. It looks like the future Ravenel Bridge will be wholly protected against man and nature. But there was one more engineering challenge. Because the bridge is diamond-shaped, it needed a little help around the midsection. Hidden inside the crossbeams are steel cables that run from one side of the tower to the other and actually hold the whole shebang together.
If, for some unbelievable reason, they all broke at once, the actual bridge would collapse. It would be catastrophic.
That's where Dave comes in. He's making sure that these vital tendons are protected from the #1 enemy of steel, rust. Dave's the superintendent on the other tower, but today he's here on his day off.
How about you, Brian? One of my nicknames out here is Super Dave. I'm not sure how I got that, but that one stuck a few times. Elevator's broke down.
Sometimes Dave feels a little out of place. Not because he's on the wrong side of the bridge, but because he's on the wrong side of the Mason-Dixon line.
I'm from a small country town in Maine called North Noblesboro, Maine. For the most part, I've had some good southern hospitality. I've run into a couple folks that had some prejudice against Yankees, but that's okay. I try to distill that we're all Americans.
Dave's also the bridge's leading expert on something called grout, a unique sealant that protects structural steel and cables from rust. The crew mixes up their own special batch right on site by combining cement powder with water. Then it's pumped into nooks and crannies that regular concrete can't reach.
That's holding 75. Let me pinch it off, see how far it goes up.
In fact, when it comes to grout, Dave's a bit of a nerd.
It's like a real expensive coat of paint on a Rolls Royce. It's what will keep this bridge together for 100 years. So if we don't get this perfect, then we're in trouble. Are you seeing any grout yet?
While the guys work on the grout topside, Dave heads underneath the main span at the crossbeam, where the end of the tendons are locked in place.
There's 4 million pounds of force right on this one tendon.
It'll keep them from corroding and ultimately keep the road deck out of the Cooper River.
We're going to see some action here in a minute. All right. Hold it right down a little bit, Russ. All right, Grip, you bleed your cap out one more time. I've got Grout here. Okay, do you count down for the shut-off?
Okay, pump shut off in 3. 1, 2, 3. Pump is off.
If we do had any type of air bubbles in these lines, I just need to make sure this stays above that, and they'll just assure me that whatever grout's left in these tubes will keep that cap full. Am I getting heavy, Russ?
Nah, man.
All right.
It's a beautiful thing. A crew boss and a whip-cracking bridge inspector pitching in together.
Freezing cold right now.
Russ Touchberry better enjoy this moment while he can. Day 4. The steel framework is up, the elevator's fixed, and the cables are tensioned, ready to hold up the 200 tons of new concrete destined for this week's road deck section. Incredibly, the men have fought their way back on track.
I need a 10 right there. I don't need to pile up on that.
But the delays of the previous 3 days have deck foreman Alan Griffin moving at warp speed. This guy is busy.
I got 16 things going on at the same time here. Just put the shackle through right here, and we'll put the chains up on the hooks. Creative engineering.
He doesn't much care for the limelight.
I'm running around with a microphone on me. So good. Don't even ask.
But he can't hide from us.
Easy on the phone.
Alan keeps tabs on just about every job on the deck, no matter how small.
Oh, thunderduders, yeah, I'll get it. We'll need to go around the hook. We'll need the big blue. Just leave those on the hook, because that's going to be ours permanently. I don't know whose they are or whose they were, but they're mine now. Let's go ahead and swing to your right. Go ahead and boom in. Boom it down.
Alan's a micromanager. He has to be. There can be no slowdown or deviation from the tight confines of the construction sequence.
Easiest way to describe this would be a seesaw. If you're sitting and you have 2 equal weights on both sides, that seesaw is going to be balanced. Both people are going to be up on both sides.
The weight load on the bridge must be carefully balanced at all times. If they build too many sections on one side, the tower could topple. Right now, Alan is running into problems. To get the steel and concrete they need onto the deck, Alan relies on the ringer crane, a 400-ton rotating behemoth mounted on a band of steel. Because the crane rides on a barge, it can be moved around the job site to tackle just about any task. It's the bridge builder's most versatile tool. But there's just one of them, and right now it's parked on the wrong side of the tower. And there's no tugboat available to move it.
Ringer can't reach it. Can the forklift hook the darn thing? Either that or I got a ringer hanging in the channel doing nothing, costing $1,000 an hour. See what we can do about getting any of those slabs up there.
It takes 5 hours, but by 1 o'clock the crew finally gets their tug, and the work can begin. They've got a mere 3 hours to lay this section's 12 panels. After that, they lose the ringer crane again to the crew on the other tower. At 200 feet with only a safety cord to catch them, it is extremely dangerous work. Time is critical, but they can't sacrifice quality. To get the job done, the crew must rely on the crane and its operator. And that pushes them both to the absolute limit of their abilities.
What we're looking for as we're setting this, we want to cover at least 2 inches of concrete over the lip of the steel. I need to have that on all 4 sides. Now, sometimes we have a little bit of variation in that slab. So what we try and do with that is, if there's, say, a ½ inch of variation, is split that difference where I have a 1/4 inch off each side, whether it be north, south, east, or west. To get it as absolutely square as we can, where we can have as much weight as we can on the steel itself. This stick right here has 280 feet in it, and he can move that thing within 1/8 of an inch of tolerance of what we need. They have that much control down there in that friction rig.
Alan, the chief rigger, and the crane operator stay in constant radio contact. The trio must make thousands of minute adjustments to guarantee that the 16-ton slab sits squarely on the beams.
You need to go this way, just there.
They must get it to within a fraction of an inch.
He's good on that corner, you're good on that corner. It's got to be about right. Take it down. Drop it down.
With the panels laid, they waste no time knitting them together with rebar. After the concrete is in, the deck will be transformed into one giant slab. But as always, before anything can go forward, the last phase of construction must be inspected. This afternoon, panel inspection falls to Russ Touchberry.
Moving slowly.
Don't let this boy's baby face fool you. He may be only 25 years old, one of the youngest on the crew, but he's got an awesome responsibility.
Couple things I noticed up on the deck. The sidewalk slab where the hurricane tie down is supposed to go through, it's supposed to be sidewalk slab 10510. They put 20515 in its place, and it doesn't have a block-out hole for the hurricane tie-down up top.
I wonder why they did that.
It's his job to hold the bridge supervisor's feet to the fire, looking for construction errors and then standing his ground to make sure they get fixed, no matter what the cost in money or time. This slab may look like all the others, but it's not. It's the wrong piece. But that's not the worst of it. In the process of trying to shoehorn it into place, one of the guys pulled a big no-no.
Another thing it looks like they did up here is they heat bent some of the rebar so it didn't conflict with some of the tie-down stuff that goes in the top flange of the edge girder.
Russ has discovered a major error, and Pete Gibbs, the main span superintendent of construction, wastes no time to arrive on the scene.
Now on the other side, you got one on the inside like this, so we need to find out what the number is on that slab down there, check it with what goes here. This one's going to have to be taken out, the other one's going to have to be put this place.
It's supposed to be 10510. The panel that's supposed to go here is 10510.
Pete is pissed. He'd probably like to shoot the messenger. But the chief rigger, Eastwood, steps up to the plate and takes the blame.
We were under the assumption that this was a typical panel, and apparently it's not. There's a corresponding hurricane restraint hole, as you can see in the corner of the slabs, and wasn't in that one. The panel on the barge is unfortunately not stenciled, so no one knew the correct number. And now we put two and two together. We know where the panel is, so we take this one down and put the correct panel where it goes.
But Pete has bigger headaches than replacing the edge panel. The bent rebar could be a much bigger problem. Because each piece is cast and slated for a specific place, there is no replacement waiting on the barge.
We can get by with one set.
Work will have to stop until it's resolved, which puts Pete between a rock and a hard place. And under the hot South Carolina sun, things can't help getting a little heated.
Hey, Ian, I don't know what you got going on, but we've got quite a few issues up here with these plates going into this pour. And various things that we're not going to be able to pour this thing till we get some answers on. So as soon as you or Dennis or somebody that can communicate with the designer can get out here, the better. I don't even think you know what all the issues are, Ian. I mean, has anybody told you what the heck's going on with these things? Where they're falling, where they're not falling, what we're going to have to do to fix them? We've got rebar that's coming out of the slab, the precast slab. It's been heated up, bent out of the way, and that's not going to fly either. We need an answer on all these different things, so I need a little bit of input from you guys.
They'll have to come up with a fix, and one that will satisfy the senior engineers and designers. It's a slow but necessary process. Finally, a decision is reached.
Cut that off right there, and then we'll just splice from that point on. I think that's really what's going to have to happen.
The best thing to do is leave the bars out.
I'd say leave the bars out for right now. All right? Make sure you got a chipping gun ready to go, a welder, because it's coming.
At $1,000 an hour, the ringer crane is called back to fix a problem that should have been avoided. With a project of this scale, hiccups like this are a fact of life.
We take steps back every day, but fortunately we've got enough people out here that's been in the field for quite a while, and we managed to keep moving forward.
Having to be the bearer of bad news up on the bridge, it's not surprising that Russ likes to hightail it out of town whenever he can. And in the South Carolina low country, there's nothing more stress relieving than going shrimping.
My pop always said work hard, play hard, and a lot of hard work on the bridge, a lot of work all week long. And if you get a chance to walk down the creek with a 40-foot seine net for a couple hundred yards, it'll help you relax a little bit. We've caught sharks, stingrays, of course fish, shrimp, squid. Also, you get some crabs, and one time we caught an alligator out here. It's a good sandy bottom, and you look for a tidal creek, and when the tide starts going out, right towards the end, it'll slow down just a little bit, and that's when you want to try to shrimp, and you walk with the current on out with a 40-foot seine net or whatever you have, and you hope for the best. You cut straight up on that sandbank.
Shrimp a la swamp. Day 5. With the panel problem solved, the task of the day is to pour concrete into the gaps between the panels. Though it may not look like much, the infill makes up an entire quarter of the road surface. It ties the loosely placed panels into one monolithic road deck. But the crew is far from ready. They don't have enough water on hand to keep the concrete moist. And the rebar isn't set either. Foreman Bill Burke is orchestrating the chaos.
Well, you better get a boat, get 2 buckets, get out to that barge, and get me 2 buckets damn pure. Because we could have put that on the hook first thing.
Who's watching the rebar?
They're doing it right now. He's on it right now.
Get him up there to cut any rebar that's in the way out. Now, let's get those sleeves in. I got to hold them all down while we pour. Till we get it poured, whatever it takes.
Okay, now I need you to jump back over the other side real quick. All right? Stop what you're doing right now. Stop this. Over on the other side. Need you over there now. On that edge form. Now.
Water down on that barge. We gonna be able to get them in a pan or
get them on the damn elevator. I got a mud bucket on the hook right now.
This guy
No, you can't steal no guys from up here. No guys. I'm underhand already. Huh, pick up the damn pace. The hell's working hard and you're just LL Cool J over here. 1, ease up, on down. Good, touch down, hold that.
Once the concrete gets here, how much time do you guys have to get it poured, typically?
Typically about 2 hours. That's from the time that it gets batched at the plant. And it gets out here from the time it gets dropped off at the hill onto a barge and gets shipped out here. That includes all that time. And this stuff is a special mix, and it kicks off, it's an 8,000 PSI, and it kicks off real rapid, turns into brick. And if I don't get it in the hole real fast, it'll harden right up on it, and it makes it a lot harder work.
So how are things looking for today?
I don't know. I'll let you know when the first bucket comes up. Right now, it's been pretty hairy scary, trying to get this prepared for it.
When the concrete arrives, it'll be a frantic push to get it poured into the gaps just before the concrete becomes as hard to handle as a truckload of super glue.
Come on, come on, come on! Well, guess what, Bubby? It is coming. It is here.
Good.
All right, Chris, we're going to bring it in onto the south side of the east derrick here. There's a little runway between state pipes we're going to try for this shot. You need to vibrate it. That gets your air out of the concrete and make sure that you're getting it proper down underneath. You can get an air pocket like that, and that's no good. So you gotta put the vibrator to it. The mud's coming up stiff. I'm worried about this second bucket off this barge. If the first bucket like this is coming up real stiff, I guarantee you that second one's gonna come up a lot stiffer. Good, get out of the way. Everett's a senior up here. I'll put my input in. Hopefully he'll usually say we'll go with it, go for it, and we'll work it. Or he'll make a judgment call on it saying it's just too bad. What it is, it gets too tight, too tough, and it won't flow around the rebar correctly. And we need it to get around that rebar correctly, or the state won't buy the bridge. There's a lot in here.
Everett makes a call down to the barge where the rest of the concrete is waiting. He makes an agonizing decision. Dump the concrete.
The truck gets a train, bad traffic, anything. All that takes away from the time you've got to get it in the hole. It's a race from start to finish.
Time is of the essence. They need to dig a ton of rapidly hardening concrete out of the hopper, or else it will take a jackhammer to get it out. The concrete on the barge is rejected. With the first load mostly wasted, the guys still have the majority of the work ahead of them. But this is no time to worry about the setback. The second truckload has already arrived. It's being brought up in the hopper. There's an equal possibility that it will be stiff. It is stiff. But if he keeps rejecting loads, these guys could be here all night. So Everett decides to go for broke and deal with it. It's a risky call, and it's a real struggle to get the concrete to settle smoothly into the gaps. Their determination pays off, and by the end of the day, the road deck is finished. That's one section down this week, and 43 to go. A long work week on the bridge is over. But a hard day's work wouldn't be complete without a beer at a local bar, Moe's Tavern. 200 feet up in the air, these guys are as tough as they come. Get a few beers in them, though, and they're just a bunch of softies.
I'll tell the world my wife is the most perfect wife in the whole world. And I would not be a bridge builder if it wasn't for her supporting me and taking care of me. She's perfect.
My wife doesn't like it, but she's down here to be with me and support me. We've got a 3-year-old son, or he'll be 3 here in another month or so. I can't go a day without seeing him. This is the reason why I'm here and work so hard.
Show him, pull it up. Show him. That's his wife right there.
Can't take her with me, but I can take the brand with me.